Hello my dears, thank you for being with me in another training video from the Python programming language training series. Okay, so far we have covered various points about lists. We saw different examples and methods. We also did a number of small projects to help better understand the subject. I have provided you with the projects and their related codes in the form of attached files. Pay attention that the codes that we write here in the console here are only for practice and will not remain. You just have to use them while watching the video. My suggestion to you is to spend much more time to practice programming. Try different examples and situations by yourself to achieve sufficient skill. So far you have known a list as a data structure. You now know that related data is stored in lists. You know the appearance of lists. You know that the data in the lists are inside the square brackets, and you know that the elements in the lists are separated by commas. This is a summary of the lists. You see that this data structure powers up with extraordinary methods. For example, you could dynamically enlarge and reduce the lists. You have seen that different things can be done on the lists. For example, you saw that you can apply the for loop to list. Pay attention to the point that when we say that there are different data structures, it means that these lists have some weaknesses that the Python programmers realized that there is a need for other data structures. It means that we should know where lists can be used functionally and where it is not possible to use them, or if it is possible, lists are not the optimal choice. We should know that in cases where lists cannot be used, what is the appropriate data structure alternative. Choosing the right data structure depends on many things. For example, it depends a lot on our data structure, or for example, it depends on how we want our data characteristics to be. In the rest of this chapter, we will talk more about this and introduce other data structures. Here we want to introduce another data structure to you. If we want to talk about the weaknesses of lists, we can say that, for example, if you have a collection of similar objects like what you have here, let's do it. For example, let's define the list A includes some numbers, for example. Okay, or for example, let's see. There is a syntax error. You can see that the interpreter can predict that we forgot the comma. Let's do it. Let's insert the necessary commas, and you will see that there would be no error. Okay, let's define, for example, list B including some strings. Okay. For example, there are a series of letters. For example, there are a series of numbers. When you have such things and want to store them in a collection and work with them, lists are the best choice. But if the data you want to work with has a structure, in these cases, lists are not good choices. Now we see what is meant by this structure. Let's check this out. For example, suppose that you have a series of data about a series of people in an organization. You want to save this data in Python. This data has a structure. In fact, it seems that this data contains a number of features and a number of values for these features. Our point is that the list is not suitable for storing such data with such a structure. Why should we not store such data inside the list? Let's see, is there any example here in for example, suppose that there are some data like this. This belongs to just one person. Let's see if we can use lists for storing such data. For example, list person 1 containing for example غزل لالوها okay, data scientist, Sydney, okay. To understand the answer to this question, let's look at ways to store this data using lists. Of course, notice that we know that here our data has a structure and the list is definitely not suitable for that. That means finally we want to come to the conclusion that the lists are not suitable. In this case, if we only store the features, actually the values, will be lost, and if we only store the values, the features, or for example the keys actually will be lost. For example, if we store the values in a list as person 1, we may encounter problems in establishing relationships between these stored values and unstored attributes, which are the keys actually, which are these. If we think that these are features, these are attributes, these are actually keys, and these are the values. If we just store these values, we cannot relate them to the related features, related attributes, related keys actually. This problem becomes bigger and bigger as the number of features increases. This shows that the list is not suitable for storing such data. So the first way, which focuses on values, is not a usable way. Let's check another way. In this solution, we store both features and values. In this case, our problem will be even bigger because the relationship between values and features is not clear yet. Let's check it together. Let's define another list as a person 2 and write both the features and their values without any relationship between them. We can have, for example, name غزل لالوها. We can have the feature job data scientist without any relation. We can have city Sydney without any relationship. we can have the feature height and its value 1.56 meter. Okay, we can see that our problem not only was not be solved, but also it got bigger. We do not know which value corresponds to which feature. As the number of values and features increases, this problem becomes bigger. Also, extracting information from this data structure will be very difficult, time consuming, and almost impossible if the data size is large. So list is not suitable for storing such data. What data structure is appropriate? Can you guess? To store such structured data, we have another type of data structure in Python, which is very powerful, called a dictionary. The data structure of the dictionary works very powerfully in such cases. If dictionaries are used, it will be very easy to access the stored information. As we said before, dictionaries have the same structure. Here you can see. That is, one column is related to keys and one column is related to values, which you can see it here. Python scientists also know this dictionary as associative arrays. Dictionaries are not like lists that only contain a series of related elements. Rather, there are a series of key-value pairs. In other programming languages, they use similar structures called map, hash, table. Maybe you heard about them. In Python, this data structure is called a dictionary. These keys in Python are usually strings, while that amount along with these can be of any type. Keys can be of any type, but they are usually strings. As you can see, it is very easy to identify the data that matches the dictionaries. You usually have two columns in this data. The left column is a series of tags or keys. The right column is the values for the same keys. Usually this data has several rows and two columns. Let's save the data we had this time in a dictionary under the name of person3. Okay. We make dictionaries using curly braces. We don't use square brackets here anymore. So the characteristic of dictionaries is that they must be inside curly braces. How is the data stored? As key value pairs. For example, here this string variable name is a key. This name is a key. This name is a key. We write it. After that, we put the column sign. You can see here. And then write the corresponding value. This is the corresponding value. The corresponding value. So we write it here. This is now a key value pair. From the first pair we put and want to go to the next pair, we have to put a comma. Okay? For better readability, each pair can be placed under the previous pair, but it is not obligatory and you can write them next to each other. You can write, for example, like this. You can write it in this way. For example, job, data scientist, insert a comma, another key which is city, Sydney, another comma, and the next key which is height, for example, which is 156. Actually, you can write it in integer, actually float, or write it as a string, no matter. Actually, you can write it like this, or you can do it without Disney lines. You can write them next to each other, and you can see that there is no problem. Okay, now let's restart the console once. In the variables, if you see that percentage is defined as a dict type, you can see it here. Now this percentage that we made has such a situation in the memory, like this, for example, like this. Okay. Here we have specified a series of keys and a series of values. Each of these values corresponds to a key. So know this structure. You can see that the data structure of the dictionary has a more complex structure than the list. So as we have checked the lists completely, now let's check the dictionaries completely. The first question is what is the shape of these dictionaries, which we talked about. They are placed inside curly brace. The key is placed first, then we put the column sign, and then the value. Also key value pairs that are separated by commas. The next topic is the order of entering these pairs into the dictionary. This order is maintained from version 3.7 onwards. In previous versions, it was possible to display the dictionary in an order other than the order of entry of key value pairs, but in recent versions, this arrangement is observed. Of course, this is not a very important issue because this arrangement is rarely used. Rather, the most used dictionaries are quick and convenient access to values through keys. We already talked about accessing the elements inside the lists using indexes. The same feature is also available inside the dictionaries. The difference here is that in the discussion of dictionaries, you can access the elements inside the dictionary using keys. For example, consider the phrase okay, you can say that there is no well, let's call a person tree, and we can say that there is no defined person tree in the memory because we have restart the kernel. So now we have to define such variables again. We can define, for example, a person as name. Okay, don't forget to put the necessary commas. The definition of data structures like dictionaries. Let's define the heights value as float number to see that there would be no problem if the values type be something other than strings. Okay, now let's access the value of name by the square bracket notation. You can see that because the value of the name, this key, is Ghazalaluha, you can see it here as output. You can see that the value corresponding to this key appears in the output. Also pay attention to the fact that the upper and the lowercase letters are important here and should be paid attention to. You can try different examples here. For example, if you check person, job, you can see data scientists, which is the corresponding value of this key in the defined person dictionary in the output. This access to the values through the keys is performed by the interpreter through a hashing algorithm. That is, the interpreter performs a lookup very quickly with a very optimized hashing algorithm. Of course, we have nothing to do with this algorithm. We are currently reviewing preliminary discussions here, but know that the interpreter does this optimally. You can use this way of working square bracket notation in dictionaries at runtime. That is, you can dynamically add an element to the dictionary or subtract an element from it. For example, suppose that we want to add an element to the same person dictionary. We can use this method of square bracket notation. As you can see, we can do this with the expression, for example, person age. You can suppose that we can consider person age, for example, is equal to, for example, 30. Let's define this value as integer. Okay, let's call the dict variable person, and you can see that there is another key value member added to the dictionary. As you have seen, these dictionaries can be expanded dynamically. A very practical example for this function is frequency count. That is when you have a series of data you process and keep a counter of something. Previously, we examined an example in which we defined a word and calculated the number of vowels in it. Let us run the program we had once. Okay, here let's press F5. Let's write, for example, a student. Okay, we enter a word as input. For example, here we entered a student. It tells us that inside this word is U and E. These are the vowels inside this word. You can run the program again and this time select the word teacher as input. Let's do it together. Teacher. It tells us that inside this word the vowels are E and A. But it doesn't tell us anything about the number. And now suppose we want to make a change in this program. That is, we enter a word and the program can tell us the number of times the vowels of that input word are repeated. This concept is a widely used concept that you can look into a set of data and count something. That is, we want to reach a table of vowels and the number of times they are repeated for each word. We can see it here. This is called frequency count. First of all, you can see that this table exactly corresponds to the key value structure of the dictionary. Let's first work a little with the dictionaries inside the console. First of all, we create an empty dictionary called found. Let's do it. Found. Okay. Like the empty found list we made earlier. First, let's determine what lines this dictionary has. Okay. Okay. Later, all of these lines will be assigned a value. For now, we assign the value 0 to all of these. For this, we use the same square bracket notation. We can use the square bracket notation, of course. We can, for example, remove the found dictionary and have empty one. Now we can use the square bracket notation. For example, A equal to 0, found. E equal to 0, found. I again equal to 0, found. O equal to 0 and found. U similarly equal to 0. We can call the found dictionary and you can see it here. Okay. For this, we use the same square bracket notation method. This method is a general method and is applicable for both lists and dictionaries. In this way, we add key value pairs to the found dictionary. In this way, we will have lines with keys containing vowels and values and values, all equal to 0 in the found dictionary. Now this found has a key value structure. The logic will be such that each of the vowels that were seen one will be added to their value number in the found dictionary. Of course, this updating method is no longer used by programmer. We want to do that. We want to do, for example, if for example, a vowel is seen in the input word, so with the square bracket and notation method, we do something like this. Okay, but we want to say that this updating method is no longer used by programmers because this is very frequent. To solve this problem of too many repetition, the plus equal method is used, which you can see it here. Let's do it. We can say found. For example, a plus equal to 1. Actually, these are the same. That is the expression here. This expression has a common meaning with this expression. Subtraction can be used similarly to subtract. Let's look at applying for loops to dictionaries. For example, we say that for Kavi, which are the same key value in the found dictionary, print Kavi. Let's do it for Kavi in found, print Kavi. We can see that just the keys are printed. This is the found dictionary. The vowels are its keys, and the values are not printed here. You can see that it shows the keys. To display the values, we can say print for ka, which is the key. The phrase like this. Let's do it for ka. In found, print something like this. For example, ka was found ka time now you can see that the printed phrases are something like this. A was found 2 times, E was found 0 times, I was found 0 times, and you can see it here. That is, it is a way to access square bracket notation values. There are 2 points here. If you are working with old versions of Python that do not respect the order, but this order is important to you, you can use the sorted function. The second point is that this method of working with dictionaries and applying the for loop on dictionaries is not very common because there are other features inside Python that are usually preferred in this way. Okay, I think this is enough for this video. Thank you for being with me in the 8th video of the series of Python training videos. Don't forget to join me in the next video, because in the next video we will apply all of these changes in this program. Have a nice time and stay with us.